In this problem we are asked to find the derivative dy over dx given that the curve y equal to f of x satisfies the equation y cube x square minus 6y square x minus 10y equal to tangent of y square. This implicit equation represents the graph of the function. We need to differentiate the left-hand side and right-hand side of the equation. When we apply the differential operator to the left-hand side we have d over dx of y to the power 3x to the power 2 minus 6y to the power 2x minus 10y should be equal to the differential operator applied to the right-hand side, which is d over dx of tangent of y square. First, in order to differentiate both sides of this equation, we need to use all differential rules. Let us review the power, sum, and difference rules. Actually, the derivative of x to the power n is n times x to the power n minus 1. The derivative of the sum of two functions u of x and v of x is the sum of derivatives, u prime of x plus v prime of x. The derivative of the difference of two functions u of x and v of x is the difference of derivatives, u prime of x minus v prime of x. The left-hand side of this equation has three terms. We have to differentiate each of these terms. Using the fact that the derivative of a constant is always 0, and the power rule we have d over dx of y to the power 3x to the power 2 is 2xy cube, plus 3y square x square times dy over dx. D over dx of minus 6y to the power 2x is minus 6y square, minus 12yx times dy over dx. D over dx of minus 10y is minus 10 times dy over dx. Therefore, using the sum and difference rules, we add the derivatives of all these terms of the left-hand side of the equation and we group these derivatives in two groups, those that have common factor dx over dx and those that have common factors dy over dx. Then we factor out dy over dx and obtain 2xy cube minus 6y square plus 0y plus 3y square x square plus minus 12yx minus 10 times dy over dx. Now, we have to compute the derivative of the right-hand side of this equation. We can clearly see that this expression involves a composition of functions. So we need to use the chain rule. First of all, let us recall the chain rule. Notice that d over dx of u of v of x is equal to u prime of v of x times dv of x over dx. It comes that the derivative d over dx of tangent of y square is 2y times secant square of y square times dy over dx. As a matter of fact, the differential equation d over dx of y cube x square minus 6y square x minus 10y minus d over dx of tangent of y square equals to 0 is equivalent to 2xy cube minus 6y square plus 0y plus 3y square x square plus minus 12yx minus 10 times dy over dx minus 2y times secant square of y square times dy over dx equals to 0, which is also equivalent to 3y square x square minus 12yx minus 10 plus minus 2y times secant square of y square times dy over dx, which is equal to negative the quantity 2xy cube minus 6y square plus 0y. When we expand after multiplying by negative 1, we have minus 2xy cube plus 6y square plus 0y. Finally, when we solve the last equation for dy over dx, we see that the derivative of y with respect to x, dy over dx is equal to the ratio 2xy cube minus 6y square over 3y square x square minus 12yx minus 10 minus 2y times secant square of y square. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus-related videos covering limits, derivatives, integration, and many other calculus topics.